Producing cyclohexene from cyclohexanol. Why do we even do these 3 steps? Distillation, separation, purification. And I think that once you know why and the understanding behind it, it's much easier to learn it and ultimately memorize it. So in the dehydration of alcohols form alkenes, the mixture at the end contains a product, reactant, acid, and water. And distillation is used to separate chemicals. It's a technique which uses the fact that different chemicals have different boiling points to separate them. And that's why we do this, because in the dehydration of alcohols from alkenes, that mechanism, the mixture at the end contains a product, reactant, acid, and water. It's going to be impure. We want to separate the chemicals using the fact that these different chemicals have different boiling points to separate them. Stage 1 distillation. Add concentrated H2SO4 and H3PO4 to a round bottom flask containing the cyclohexanol. Mix the solution by swirling the flask and add 2 to 3 carborundum boiling chips. These make the mixture boil more calmly. Mixture should be gently heated to around 83 degrees Celsius using electric heater / water bath. Chemicals with boiling points up to 83 degrees Celsius will evaporate. The warm gas will rise out of the flask and into the condenser, which has cold water running through the outside, turning it into a liquid. Product can then be collected in the cool flask. Heat, reaction mixture, water out, water in condenser, cooled flask, impure product. And in a lot of the cases, it asks you to either label the diagram. They'll give you a diagram, say what's that, or draw the diagram. So you need to memorize these diagrams as well. Stage 2 separation. Product collected in a cool flask after stage 1, after distillation, but still contain impurities. Therefore, we transfer the product to a separating mixture and add water. Why do we add water? We transfer the product to a separating funnel, not a separating mixture. Transfer the product mixture to a separating funnel. Transfer the product mixture to a separating funnel. Add water to dissolve water-soluble impurities, therefore creating an aqueous solution. Allow the mixture to settle into layers. Drain the aqueous lower layer, leaving the impure cyclohexene. Allow the mixture to settle into layers. Drain the aqueous lower layer, leaving the impure cyclohexene. Stage 3 purification. Drain the cyclohexene into a round-bottomed flask. Add anhydrous calcium chloride and stop at the flask. Let the mixture dry for at least 20 minutes with occasional swirling. Cyclohexene still has small amounts of impurities, so distill the mixture one last time. And they go impure cyclohexene, aqueous lower layer, unreacted cyclohexanol. Move the stopper to run substances out of the separating funnel. So stage 2 purification, let's go through this again. Drain the cyclohexene into a round bottom flask. Add anhydrous calcium chloride and stop at the flask. Let the mixture dry for at least 20 minutes with occasional swirling. Cyclohexene still contains tiny bits of impurities, so distill the mixture one last time.